Hey Year 11, so last lesson we worked out how to find the R value using our calculator and also being able to interpret the R value in terms of telling us the strength of the relationship between the two variables, but also the direction as well. But today in this lesson, we're going to be looking at 7F, which is using the least squares line to model a linear association. So basically what we're doing is coming up with a line that shows I don't know, the trend or direction of all the information that we've been given, all the data we've been given. So we might have been given a heap of data and we've put in a scatter plot and it has come out like this. I can see that it looks like we have a positive trend. Don't know the exact R value, but what we're trying to do is come up with a line that kind of shows that trend. So it's a line of best fit is what they can call it as well. So it might look something like that. Can we see that that line is kind of showing the direction or the trend of all this data? Now, we're going to be using our calculator to come up with the equation of this line here. Now, there's going to be a different equation for different data sets, but what we need to realize as well is that, do you see how all the dots aren't on the line? They're never going to be exactly on the line. This line is just used to make predictions, so it's never going to be exactly on it. The way the calculator or we can come up with this line is, you see how each of these dots isn't exactly on the line. I'm not going to choose every dot, I might just choose a couple. So this one misses by a fair bit. See how there's a good distance there that it misses for? And if we look at this one, it misses just by a little bit. And this one here just by a little bit as well. The way the calculator came up with this rule or this line here would be, it adds all these residual lines, which is the error. So all these orange lines up for every single piece of data that we have, and comes up with an equation for a line that means the distance of all these lines is a minimum. Okay, so if we add up all these orange lines, we want the minimum distance, and that's how it comes up with that line there. So let's go down the page here. When we find the line out, and I'll show you how to do that in UCAS in a sec, it's going to come in this form here. So hopefully you've seen something like this before. It's a linear equation. You might have seen it as y equals mx plus c. We've just changed the letters from A to B. But as we can see here, A means the y-intercept of the line. So if we look up this one, the y-intercept is here. And B, which we can see here, is the slope or the gradient of that line. So we can see this one sloping upwards, so it's going to have a positive B value. All right, so let's start using our calculator. We're going to go through all these steps here and work out the line of best fit for a set of data. So you can pause and have a look at these steps if you like, but I'm just going to move straight over to showing you on the calculator. Okay, I might use question 1 from your exercises to show you how to find these least squares regression lines. So let's have a look here. Alright, so the table below shows the weight in kilos and blood glucose level of 8 adults. So we can see that here. The first thing it wants us to do is to construct a scatter plot to display this data with weight as the EV. Now, EV means explanatory variable, which is the same as independent variable. So that means weight is going to be on the x-axis for us. So what I've done is I've already put the data in, so you didn't have to watch me do it. It wanted us to do a scatter plot. So after I've entered this data, I need to start up one of these documents. There's all our dots, but we need to make sure we put the EV, or independent variable, just here, which was weight, it told us, which means the other one's going to be glucose. Cool, so there's our scatter plot, which it wanted us to do for the first question, so A. The next one, which is the main sort of thing we're learning and doing in this exercise. Fit a least squares regression line to the scatter plot and determine its equation. So the way you do that is the steps that we had written down just before. So we're going to go to our data and statistics, we've got it. We've identified the variables as well. We need to go to menu, where analyzing regression, and we want to show that linear equation in this form here, a plus bx. There we go. So it's showing us our line of best fit, and here's our equation as well. So let's go back to the questions. So we've fitted the line. It's given us the equation as well. It says, write the equation of the regression line in terms of the variables glucose and weight. All right, so let's go back over here. It says here y equals 50.8 plus 0.62 times x. We just need to swap those x's and y's for what the variables actually mean. So y is glucose and x is the weight in kilograms. So this would be glucose equals 50.8 plus 0.62, or however many decimal places it wanted, times weight. So that would be the answer to that question. And the last one, D, that's what we did in one of the previous exercises. So determine the correlation coefficient to 3 significant figures. So let's try to find that correlation coefficient again. All right, now hopefully you remember. If you don't, this is how you do it again. You just start up a normal calculator document. We've already got all the information we need in here. All right, so we're going to go menu, statistics, stat calculations, and we want, which one we're looking for? Linear regression, and this one here. And you need to tell it which is your explanatory variable, which is going to be weight, which means the other one's glucose. There we go. So there's your R value just there. All right, so hopefully that's helped you with 7F. I'll get you to have a go at the questions and pop those notes into your rules book as well. Thank you guys. See ya.